All right, an object is launched upward from the ground. When t equals 1, the object is moving 30 meters per second. We're going to give the velocity function. For projectile motion, we start with v equals the antiderivative of a dt. Acceleration is negative 10. The antiderivative of negative 10 is negative 10t plus a constant. This constant is actually v0 if you wish to write v0 rather than c. Then we know that the velocity is 30 when t equals 1. Which gives us an initial velocity of 40 meters per second and a velocity function of negative 10t plus 40. On this one, we're going to find the position function of an object launched upward from a height of 5 meters if the velocity at 1.5 seconds is 80 meters per second. In order to get the position function, we must first use the antiderivative of acceleration. So the antiderivative of acceleration is velocity, which is negative 10t plus c. Same thing as last time. C is the initial velocity for this application. Then we know that velocity is 80 when time is 1.5. So our initial velocity is 95, which gives us a velocity function of negative 10t plus 95. Now we can find the position function by calculating the antiderivative of velocity. So we'll do the antiderivative of negative 10t plus 95, which is going to give us negative 5t squared plus 95t plus initial height. You could write c there again if you wanted to. Just know that it is a different constant than that one. And the given information tells us we have a launch height of 5 meters, so that is the initial height. So our answer is S of t equals negative 5t squared plus 95t plus 5. Okay, here we're going to find the velocity of an object launched downward from a height of 60 meters if the velocity is negative 100 meters per second at 0.4 seconds. How fast is the object moving at 0.75 seconds? So velocity is the antiderivative of acceleration. Acceleration is negative 10 meters per second squared. So velocity is negative 10t plus velocity initial. Whichever you prefer, I'll write v0 on this one. And we know that negative 100 equals negative 10 times 0.4 plus the initial velocity. Which is going to give us negative 96 for initial velocity. So the velocity function is negative 10t minus 96. Then it asks us to determine velocity when t is 0.75. So we evaluate the velocity function at 0.75 seconds. Which is negative 103.5 meters per second. find charge when t equals 3 if given I is 3t squared plus 1 and q of 1 equals 4. So if we have to find charge given current, q is the antiderivative of I dt, which gives us an antiderivative of t cubed plus t plus a constant, which in this case that would be initial charge. And we know that 4 equals 1 cubed plus 1 plus c. So c equals 2, and charge function is t cubed plus t plus 2. Then we need to evaluate q of 3. It says find charge when t equals 3. So we're going to evaluate q of 3. 3 cubed plus 3 plus 2 is 32 columns. All right, find the function that represents current if voltage is given as 10.8 T, and we know that I of 1 equals 9. We're also given inductance of 2.7 henries. So if we need to find current, we will use I equals 1 over L times the antiderivative of voltage. We'll have 1 over 2.7 times the antiderivative of 10.8 T I prefer the constants to go out front. And when we reduce that fraction, we're going to end up with 2t squared plus c is the current function. Now, we need to determine the value for c, and we can do so by replacing current with 9 and replacing time with 1. And we get the initial current, which is the C, as positive 7. So our answer is I equals 2t squared plus 7. Now we're going to find voltage, and we know the capacitance and the current. So we use V equals 1 over C times the antiderivative of I. And I'm going to rewrite the square root of t as t to the 1/2. Now we've got a lot of simplification here. 1 over 0.5 is 1 over 1/2. 9 times 2 is 18. 2 times 3 is 6. And we have t to the 3/2 plus c. And 1 over 1/2 is the same thing as 2 over 1. So I'm just going to flip that fraction. 18 over 6 is 3. So 6t to the 3/2 plus a constant. Now we know that v0 is 30 and our constant is v0. So the voltage function is 6t to the 3/2 plus 30. And we're asked to find v of 5. So 6 times 5 to the 3/2 plus 30. Now that is the exact value. If we were wanting to approximate, which since this is an application, I'm okay with approximating, that is approximately 97 volts. Okay, so we're looking at an online retail store and they're doing a flash sale and studying their profit. And they're able to determine R prime is x squared. And then it says they have a fixed cost of 50. And our units are in thousands, so that would be 50,000 once we're all said and done. Now, we want to know the profit projection if the sale were extended, resulting in 90,000 views. So P equals R minus C. That's the same thing as saying P prime equals R prime minus C prime. And if we took the antiderivative, we get right back to P equals R minus C. Now, we're only going to need to do that for revenue, which is R prime is x squared, and then we have a fixed cost of 50, so 1/3 x cubed plus a constant minus 50 is the profit function. Now it's inherent that initial revenue, which we could call R0, is 0. So the profit function is 1/3 x cubed minus 50. Now it says we want to find profit at 90,000 views, and the units are in tens of thousands. For the number of views. So we need to evaluate P when x equals 90. I'm sorry, the units are in tens of thousands. I missed a 0 there. So 90,000 90,000 views is x equals 9. And that is 193. So profit is $193,000 at 90,000 views.